Okay, so let's go ahead and break down what this title is saying. Um, real, right? Real are, they're not your imaginary numbers. Okay, there's no I's or anything like that. So real are just like your number line. Okay, so these are real numbers, not complex or imaginary. Okay, zeros, all right. There's many interpretations of this, but just to kind of get our feet wet concerning this, it means x-intercepts, roots, or factors. Okay? There are differences between them, but again, we'll talk about that in a second. Polynomial, all right? We've used those types of functions before, such as, x squared plus 6x plus 9, that's a polynomial. Or x cubed plus 5x squared plus 3x plus 1 is a polynomial, x to the fifth plus x to the fourth plus 7 is a polynomial. What is not a polynomial are x raised to the square root of 3 plus 4x squared plus 1, or 1 over x to the fourth plus 2x plus 5. Okay. So the difference between what is a polynomial versus what is not a polynomial is what it's being raised to. So the power here, cannot be a radical, right? Cannot have a radical in the power, and then the power cannot be negative. So if I were to, rewrite this, this would be x to the negative fourth. Okay. So because of that, it's not a polynomial, okay? So you can't do anything to the power, just regular integers. Can't have negatives in them, radicals, or anything like that, okay? All right. So these right here are polynomials, right? Those are examples of polynomials, and you can have an infinite amount of terms. Okay, so then let me talk a little bit about we interchange these a lot, but they're different. X-intercepts, roots, factors. So let's talk a little bit about the difference between a factor versus a root. Okay. So if I have this polynomial, x squared minus 7x plus 12, okay. If we were to factor that, we would get x minus 3, x minus 4. Okay. So these are your factors. Okay, those are your factors. That one and that one. Okay, those are your factors. Those are factors. Now, if we want the root, okay, if we want the root, then we would get those factors. So the x minus 3, right, and the x minus 4, and we would set them equal to 0. Okay, so it would be x minus 3 equals 0 and x minus 4 equals 0. So x equals 3 and x equals 4. They are your roots. These are the roots right there. Those are roots. Okay, and they're also called zeros. Roots, zeros. Okay, all right. Or they're also called x-intercepts, where it crosses the x-axis. Okay, so the actual number that you get are your roots, okay? They're your x-intercepts or your zeros, okay? All right. So let's say that we wanted to, um, we want factored form, okay? And then we want the root. So factor form. Mm, okay, let me move this here. Okay, factor form, and then the root here. Okay, so if we have the factor form, so let me draw a table here. Okay, so if we have the factor form, all right, so if I have, say, again, back to the x minus 3, x minus 4, right? The roots in this case would be 3 and 4, correct? All right. If I have x minus 7 and x minus 5, the roots will be 7 and 5. Okay. What if we had x plus 2 and x minus 6? Well, the roots in this case would just be the opposite, right? So plus 2 would now be a negative 2, minus 6 would be a positive 6, okay? So the roots will always be the opposite of whatever is in the factor. This was a negative 3, now this is a positive 3. This is a negative 4, this is a positive 4. Okay? So those are our roots. Okay? So give me 1 second. Okay, here's another thing we need to think about as we do our first problem is so if I have let's call it, let's say reduced. Okay, so if I have x to the fifth power and I divide that by x, right, this is going to reduce to x to the fourth. Okay, it reduces by 1 power. Again, if I have x to the seventh and I divide by x, that will reduce to x to the sixth power. Okay? All right. So if you divide it by 1x, all right, it's just going to reduce it by 1. All right. So we need to think about that um, as we do this problem. So what we want to do here is two parts. We're going to use synthetic division and we need to find the zeros. So technically, let's find the zeros first and then use the synthetic division. So let me um, do the synthetic division first so you have an idea of how to do it. But technically, you should have learned this in either intermediate algebra or introduction to algebra. So before you come in, but let me just refresh your memory. So let's say we have x plus 3 is a factor of, say, 2x to the fifth plus 5x to the fourth minus 2x to the third plus 2x squared minus 2x plus 3. Okay, so this is a polynomial. This is an example of polynomial. All right, and what we want to do is we want to figure out whether x plus 3 is a factor, or we need to show that it is. Okay, so how do we do that? So to do that, we do what is called synthetic division. So what I'm going to do is um, I'm going to put the coefficients on the top line. Okay, then I need to multiply and divide. Sorry, multiply and add on this line. Okay. All right. And then I'll have this, it looks like part of a rectangle. Okay. And then I'll have my root over here on this side. Okay. All right. So what are the coefficients? Well, they're just the numbers in front of the variable, right? All of these are your coefficients. Okay. Make sure if there's a negative, we tack that on. So, all right. So it wants us to take the coefficients and line them up. So we have 2, 5, -2, 2, -2, 3. Okay. So those are our coefficients. And then we draw our part of this rectangle thing. All right. And then we need a root. So remember, x plus 3 is a factor. The root would be just the number itself, but be the opposite. So in this case, that would be a -3. Okay. So if we don't do +3, it would be because we would solve this for x and we get -3. So -3 is the root. Okay. So again, we set x plus 3 equals 0 and then solve. All right. And then we get that. All right. So, so how do we do this? So we take that number 2 and then we bring it down. All right. And then we're going to multiply the root and the number we brought down. So that'll be -3 times 2, which gives me -6. Then we add these together, give us -1. Then we do it again. -3 times -1 will give us +3. And then -2 times +3 will give us +3. Sorry, +1. And -3 times 1 will give us a -3. We add it again. So again, we're adding on this row. So 2 plus -3 is -1. Then we multiply again. -3 times -1 is a +3. We add -2 plus 3, which is a +1. Then we multiply again. -3 times 1 will give us a -3. All right. And then we add these guys. 3 plus -3 will give us a 0. Okay. And this is what we want. All right. So if we want a result of 0. All right. If we get a 0 here, that means that x plus 3 is a factor of this polynomial, or -3 is a root of this polynomial. Okay? That's what it's saying. All right. Okay. Now, here's the other part. So remember I said if we divide by x, right, it reduces that power to 1. So it goes from x to the 5th to x to the 4th. So it's the same thing here. We're dividing by an x to the 1. This is x to the 5th. So x to the 5th divided by x to the 1, it reduces that to x to the 4th. I'm looking at the leading terms. 2x to the 5th and then x, okay? I'm just looking at the power there. All right, so in this case, if we want this in factored form, all right, well, this is the start of getting into in factored form. Again, the root -3 now in factored form becomes, right? If I go the other way, if it was a root of 3, it becomes x minus 3. It was a root of 4, it becomes x minus 4. Okay? If it was a root of -2, it becomes x plus 2 as a factored form. So in this case, so the root of -3 in factored form will be x plus 3. Okay? And then what are these? These are the coefficients, right? These here are coefficients. Coefficients. All right? All of these here. Those are all coefficients. All right? Of our new polynomial. So in this case, the first one will be 2. And since I divided by x, or x plus 3, it reduced it from the 5th power to the 4th. So now this would be 2x to the 4th okay? And then minus x to the third plus x squared minus x plus 1. All right, so these are just the coefficients. All right, that's a 1 there, a -1 and a 1. Those are just the coefficients coming from here. Okay, all the way down, right? So anyway, and then we would, factor this bottom and this second one here to get it in truly factored form. All right, anyway, so this is basically the synthetic division. So this is synthetic division, okay? Which supposedly you should have known or learned already in intermediate algebra or introduction to algebra. Okay, so anyway, that's the process of what we need to do to find, technically the step 2 process of what we need to do to find the zeros of the polynomial. Okay, so let me pause here for a second. All right, so again, we want to find the zeros, or in this case, the roots of this polynomial. So the polynomial is the pink graph, and we want to find out where it crosses the x-axis, right? Those are the roots. All right, so let's look at this polynomial. We got f of x is equal to x to the third plus 2x squared minus 5x minus 6. Okay, so before even doing this, how many possible solutions should we have? How many possible solutions should we have? Right? Well, we look at the leading term and we have a power of 3, right? So before we even do this, we know we should have at least 3 possible solutions. Okay? Or I should say 3 solutions. Okay? Because we will have several possible solutions and only 3 of them is going to work. Okay? So I'll take out the positive there and put solutions. There should be 3 solutions. Okay, so step number 1, okay, uh, we need to find the possible roots. Okay, so how do we do that? We take the factors of the last number and then we divide that by the factors of the first number, or in this case, the coefficient, okay? So the factors of the last number, I'm referring to this term here, okay? So this is our last number, okay? And then we have 1 here in the front. So this is our first number or first coefficient, okay? So our factors of 6 are going to be 1 and 6 and 2 and 3. Now, we also need to think about not only the positive, but also the negative numbers. Okay, so we want plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So those are the factors we need to consider, not only the positive, but also the negative. And then the factors of the first number are just going to be plus or minus 1, right? Okay, if we were to divide this, right, then our output is technically it's just going to be the top here for this particular example. So in this case, it'll be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, so if we were to divide that, this is the output. So in this case, all right, let's look at our total possible versus the max we can have. Max we can have. Okay. So total possible, that's what? 2, 4, 6, 8, right? Because there are eight roots that we've listed here. 2 for 1, 2 for 2, 2 for 3, and 2 for 6. Okay? So there's a total of 8. So there's 8 possible, total possible. However, as we mentioned before, that the maximum we can have is 3. Okay, why? Because we have the leading term or the leading power is 3. Okay, right here. So that means out of the 8, there should only be 3. Okay? So the question is, how do we find those 3? Well, there's actually other steps to this, but it just confuses students further, so I just broke it down to essentially 3 steps. Okay? So we found step 1. Now step 2 is synthetic division. Okay? Synthetic division. All right. Synthetic division. Okay, so again, how do we do that? Remember, we just take the coefficients of each of these terms and right? So I draw this part of a rectangle, all right? And then I need to um, um, write my coefficients here. So that's going to be 1, 2, -5, -6. Okay. Again, they're just the numbers in front of the term of the variables. 1, 2, -5. And technically there's an x to the 0 power here, but we never write that. Okay. And then you got -6. All right. So then, out of the total possible 8, which one do we choose first? I recommend going with the lower numbers first because they're easier to calculate. And once you find the lower numbers, it's easy to find the other ones. Okay, so let's try 1. Okay, if I try 1, will that work? Well, let's see. So I put 1 here as the root, okay, because that's what I have. And I start doing it. So 1 I bring down, then I multiply. 1 times 1, remember, so I bring that number down. So 1 times 1 is 1. Then I add 2. 2 plus 1 is 3. 1 times 3 is 3. Then I add again. -5 plus 3 is going to give me -2. 1 times -2 is a positive 2. I'm sorry, a -2. Okay, so that's going to give us, when we add that, gives us a -8. All right, is this what we want? No. Okay, it's not a 0. Remember, in order for it to be a root, this number here has to be a 0. It's not a 0. So that means then 1, this number here, is not a root. Okay, it's not a root. Okay, so let's try it again. So this time, let's say we pick 2. All right, so then I go through the process again. So I have 1, 2, -5, -6. Okay, this time I'm going to pick 2. Right? So I picked 1, that didn't work. I'll pick 2 this time. So I'm going to bring this down, okay? 1, then I multiply. 2 times 1 is 2. Add those, 2 plus 2 is 4. 2 times 4 is 8. Add those, -5 plus 8 is a positive 3. 2 times 3 is 6. -6 plus 6 is going to give me 0. All right? All right. Hey, that's what we wanted. We want a result of 0. So what does that mean? That means 2 is a root of this polynomial. We found one of them. Okay? So now we need to find the other 2. Once you find one, finding the other 2 is actually not that bad. Okay? But before we do that, we need to write this down in factored form. So remember what I mentioned, if we have that leading power and we divide it by 1x, it reduces it by 1, by the power by 1, from x to the fifth to x to the fourth. All right, just like how we did it over here, it became x to the fifth to x to the fourth. So in this case, this was x to the third, all right, and we had x to the third, and we divided by an x, or factored of x um, plus 2, all right, then I reduce to x squared, okay? So in this case, I'm going to have my factored x minus 2, okay? And then this reduces to x squared plus 4x plus 3, all right? All right, so then again, these are your coefficients, right? This is a 1, 4, 3. That's what we have down here. 1, 4, 3. Those are the coefficients of your new polynomial. All right, so we know how to factor this, right? This is just an x squared plus 4x plus 3, okay? So if we were to factor this, do it over here, all right, this is going to be x minus 2 times that by x plus 3 and then x plus 1, right? X squared plus 4x plus 3 is x plus 3 times x plus 1, okay? And that's equal to 0. So we set each one of them to 0, all right? And solve. So we have x minus 2 equals 0, x plus 3 equals 0, and x plus 1 equals 0. Then we solve. When we solve that, the first one, we're going to get x is equal to 2. The second one, we're going to get x equals negative 3. And the third one, we're going to get x is equal to negative 1. All right? So what does that mean? These are our roots right here. Those are the zeros or the roots. Okay? That's what we're looking for. And that's what they want. All right, so step number 1 is to write down our possible roots, right? So that's step number 1. Okay, so we take the last number and divide it by the first number, or I should say the factors of the last number divided by the factors of the first number. So in this case, we have 20. So the factors of those is going to be plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 10, plus minus 20, okay? So those are the factors for the top, and the bottom is just going to be plus or minus 1. When we divide this, again, we just get the same answer as the top, okay? So I'm just going to copy that here. If it lets me. Nope. Okay, let's write it down. All right, so plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and then plus or minus 20. Okay, so that's step number 1. So step number 2, we need to use synthetic division. Okay, so we draw a little part of a box, and then we write down our coefficients. So in this case, that will be 1, 8, 11, and negative 20. Okay, and then we just pick a root. All right, so let's pick 1. Like I said, try 1. Then if that doesn't work, try 2. Then go to negative 1 and negative 2. Again, just those lower numbers first. One of them should work. If not, then go to the next one. Okay. So let's try 1. So we bring that down. Okay. So we have 1 times 1, which is 1. And then we add these numbers here. 8 plus 1 is 9. 1 times 9 is going to give us 9. Add those. 11 plus 9 is 20. 1 times 20 is going to give us 20. Add those. That will give us 0. And this is what we want. Okay? We want the result to be 0. What does that mean? That means then 1 is a root or a 0 of this polynomial. Okay? So then we just need to write this in step number 3, which is in factored form. Okay? So step 3, we write it in factor form. So this is 1, so the opposite is going to be x minus 1. All right, and then this will be, remember, since we divide by x, this is going to reduce from x to the third to x squared. So it'll be x squared plus 9x plus 20. Okay, and then we just factor this further down. So this will be x minus 1. And then this factored, it will be x plus 5, and then x plus 4. And then we set that equal to 0. Okay, so that's going to give us x is equal to 1, -5, and -4. All right, and what are those? These are the zeros. Okay, this is the zeros that they want, or the roots. Okay, and that's how you do it.